Okay, so for lesson D04, we're now talking about two-dimensional force and friction problems. Okay, so for number one, it says that two forces act on a 3.0 kilogram block that is resting on the floor. One force, F1, has a magnitude of 12 newtons. The second force, F2, has a magnitude of 22 newtons. A, what is the net horizontal acceleration of the block, both magnitude and direction? B, what is the displacement of the block after 3.0 seconds if it starts from rest? Okay, so let's go ahead and label. They've given us a force diagram, but we still need to label it. So our force 1 is acting diagonally and has a magnitude of 12 newtons. Notice that it's pushing down as it pushes to the right. It's also pushing down on the block, which means that the vertical component is going to be adding to gravity. Okay, so it's actually artificially increasing the weight of the block. Okay, so the mass is 3.0 kilograms. Okay, but its weight is going to be more because it has additional. Now, one thing that they did not put on here is we also have the force of gravity acting on this, so we need to add that. Force 2 is acting to the left and has a magnitude of 22 newtons. Okay, and the angle over here is 20 degrees. Okay, so we have two components. We have a vertical component and a horizontal component of our F1. F2 only has a horizontal component. Okay, and then of course we have the force of gravity as well. So in order to figure out the net horizontal acceleration of the block, we are going to have to figure out both the horizontal forces and the vertical forces, because those vertical forces are going to increase the weight, which means that it's going to feel like the block has a greater mass. It's going to have a mass equivalent. Okay, so the first thing that we're going to do is figure out F net of the x direction. Okay, so the horizontal direction. Okay, and that's going to be equal to this portion right here. Okay, so we will go ahead and call this F1x. So F1 in the x direction plus our F2 because it's only in the x direction. Okay, so our F2 is 22 newtons. Our F1x, well, in order to figure that out, in order to figure out this horizontal component, that's the adjacent side to 20 degrees. This is the hypotenuse. Okay, so we're going to use cosine. So we'll go ahead and figure out what 12 times the cosine of 20 degrees is going to give us our F1x. Okay, so 12 times the cosine of 20 degrees. I'm going to plug that into my calculator because I don't have my cosine tables memorized. So 12 cosine 20 is equal to approximately 11.3. So 11.3 newtons for the x portion. 11.3 newtons, which gives us a total net force in the x direction of 33.3 newtons. Okay, and actually that is incorrect because, let's go ahead and back up just a second. I forgot something here. This 22 newtons is actually working to the left, so I need to do the 33.3 newtons, or excuse me. Okay, so I have negative 22 newtons because it's acting to the left, so 11.3 newtons plus negative 22 newtons is negative 10.7 newtons. Sorry for the confusion there. Okay, remember that we have to take into account direction. This force is acting to the left. This force is acting to the right. So we have to take the difference between those two, and we wind up with negative 10.7 newtons. That's going to come in to play later. Okay. Now to figure out the vertical component, so our F net in the y direction is equal to the F1 in the y direction, F1 in the y direction, plus our force due to gravity. So F1 in the y direction, we're going to find using the sine function, because, of course, in the y direction, we're looking at the angle, or the side that is opposite, okay, and opposite over hypotenuse is the sine function. So in order to find the F1y, okay, F1y is equal to 12 times the sine of 20 degrees. Okay, so I'll go ahead and punch that in on my calculator. 12 sine of 20 degrees is equal to 4.1. So 4.1 newtons plus, and then my force due to gravity is 3.0 kilograms times negative 9.8 meters per second squared. So 9.8 times 3 is equal to 29.4, so 29.4 newtons. So 4.1 newtons plus 29.4 newtons. Remember, both of these are going in the same direction, so the magnitudes are going to add. So 29.4 plus 4.1 is equal to 33.5 newtons. So now we need to figure out the mass equivalent. So the mass equivalent, well, we're going to work our way backwards and take the 33.5 newtons that we got when we added the two forces together, and then divide that by the force of gravity. So 33.5 divided by 9.8, our acceleration due to gravity, excuse me. Our mass equivalent is actually 3.4 kilograms. So the actual mass is 3.0 kilograms, but the equivalent mass, because of that extra force that we're pushing down on it with, makes it feel like 3.4 kilograms. Once we figure out that 3.4 kilograms is what it's behaving like, then we can figure out what the horizontal acceleration of the block is because of our net horizontal force. So we're talking about horizontal acceleration. Well, our net horizontal force, remember I said it was going to come into play later, our net horizontal force was negative 10.7. So negative 10.7 newtons is equal to our mass equivalent, which is 3.4 kilograms, okay, times acceleration, which is what we're looking for. So if we divide both sides by 3.4 kilograms, okay, we get an acceleration of negative 3.1 meters per second squared, which means that it's 3.1 meters per second squared to the left. So we could say that the acceleration is 3.1 meters per second squared left. Okay? So that takes care of part A. Part B, what is the displacement? Well, the displacement, we are going to use D equals initial velocity times time plus 1/2 acceleration times time squared. since we know that it's starting from rest, that means that our initial velocity is equal to 0. Well, 0 times t is 0. So we're going to plug in what we know. 1/2 times our acceleration we just found was 3.1. Actually, it's negative 3.1 meters per second squared, okay, because it's going to the left, okay, times our time squared, okay, and our time was 3.0 seconds, so that's 1/2 times negative 3.1 meters per second squared times 3.0 seconds squared. Okay, so we'll go ahead and just work those numbers out. If I take all of that, 1/2 times negative 3.1 times 3.0 squared is just 9, so we'll just say times 9, and we get a total displacement of negative 14 meters. Or another way that we could write that is 14 meters left. Okay, number 2, I'm going to go ahead and get set up for you, and then I'm going to let you take over and do the rest of it. It says a 1.50 kilogram object at static equilibrium. Static equilibrium. In other words, it's not moving. Not moving. Is attached to a ceiling and a wall by 2 ropes as shown here. Theta is equal to 40.0 degrees. A, what is the tension in the diagonal rope? B, what is the tension in the horizontal rope? Well, if it's not moving, okay, that means that we know a few things. Okay, so the tension means that we have a force acting in the up direction, okay, because it's pulling it up towards the ceiling. We have a force moving left, and then we have a force moving right, okay? And then, of course, we have the force of gravity going down. So we have force of gravity, we have the force of tension in the x direction, okay? We have an equivalent force of tension in the y direction. Okay, let me back that up just a little bit. Okay, so we have a force of tension in the x direction there, and then we have force of tension in the y direction. Okay, the force of tension in the y direction is equal to, so the force of tension in the y direction is equal to the force of gravity. Okay. The force of tension in the x direction of the diagonal, so the force of tension of our diagonal in the x direction is equal to the force of tension in the x direction of our horizontal rope. Okay? And then the overall force of tension of the diagonal rope is going to be found using our tangent, okay, trig function, okay, because we're going to find the different portions of this using theta equals 40 degrees, knowing that this portion is opposite. Okay, this portion is our adjacent, and then our overall diagonal here is our hypotenuse. Okay, and because this is in static equilibrium, that means that the forces in the x direction have to cancel each other out, and the forces in the y direction have to cancel each other out because nothing is moving. Right? So all of this starts with figuring out what the force of gravity is. Okay? The force of gravity, of course, is our mass, which is 1.5 kilograms, times acceleration due to gravity, so our 9.8 meters per second squared. Remember, it's heading down, so if you want, you can make it negative just to make sure that you carry that through. In the y direction, it's actually going to be the opposite. I said that they were equivalent. The magnitudes are equivalent. Of course, the force of tension is acting in the opposite direction as the force of gravity. Okay? So once you figure out the force of gravity, the opposite of that is your tension force in the y direction. Okay? Then from there, you can set it up by taking that force of gravity, so our x direction. Okay? So F diagonal of the x is going to be equal to tangent of 40 degrees times your force of gravity that you just calculated. Okay? And then your overall diagonal force, the magnitude is equal to the force of gravity times the cosine of 40 degrees. Okay, everything else is up to you. If you have any problems, feel free to come and see me.